Melvin and I have a problem. He is very fussy about his food, and I need to make sure I have exactly enough grain for him to eat this week. So I am trying to measure out all the grain that I have for him. And the grain is in this container. Now, it happens that I know the weight of this glass bowl from, just already, so I'm going to weigh the whole thing and subtract out the weight of the bowl at the end. So just ignore that part. Don't think about it. We're just going to think of weighing this whole thing. So I take out my kitchen scale and I weigh this, and it tells me that it is 631 grams. Looks good, right? But just to be sure, I'm going to use another scale. And this is 632 grams. Okay, those are close, but they're not exactly the same. That's a little bit worrying to Melvin. So I want to know more. I want to find out what really is the real weight. So I actually get a whole bunch of scales. These are all scales that I found for sale on the internet, and we could weigh on a couple of them. Let's see. This says 631. This says 630. This says 626. And this says 629. Okay, what do we do? The scales are giving us a couple of different answers. I could pick just one number and tell Melvin, but how do I know that that number is any more accurate than the others? Here's an idea. Not all these scales are equally good instruments. They're of varying qualities. Some are poorly made while some are more well-crafted. So maybe we can choose a scale that we think is very high quality. Now, what makes a scale high quality? It can be wrong in at least two ways. First, a scale could consistently overestimate or underestimate weight. Now, here's an example. I'm going to take one of my scales, and I have something here which is a calibration weight. This weight is manufactured to be exactly 2 kilograms, so we can put it on the scale and just see what happens, knowing that this really is 2 kilograms. So I'm putting this on. Okay, and the scale says that it is 2,001 grams. I'm going to do it again. 2,001 grams. One more time, just to be sure. It is still 2,001 grams. Okay, so in this case, we have a scale that is consistently overestimating the weight of this calibration weight by about 1 gram. It always makes that error, every time, and it's always in the same direction. It's always just 1 more gram than it really is, and it's always by the same amount. So we would say in statistics that this scale is biased. It consistently gets the answer wrong by the same amount. Another way a scale could be wrong is if it gives us inconsistent measurements, even when weighing the same object. Now we're going to take a look at a scale here. This one, the reviews happen to be, quite questionable. A lot of unhappy customers with this one. And so I'm going to place our weight on it again. And it says it is 1,995 grams. I'm going to do it again, take it off. Now it's 1,992 grams. Now it's 1,993 grams. Oh, it just went up to 4. Okay, but the point is that every time I'm weighing this, this weight, even though it's the exact same object, we're getting a slightly different number every time. So that means that this scale is not particularly reliable. It's noisy. So does that mean that we should completely disregard the scales, knowing that these are all imperfect in some way, particularly that one of them is biased and this one might be noisy and biased? Well, not so fast. Even though they are imperfect, we can still learn something. If I'm able to use an object with a known weight like this cylinder, then I could identify how biased a scale is. And that means that, since I know it always subtracts or adds a certain amount to the true weight of whatever it's measuring, I could use that knowledge to correct its measurements in the future. All I have to do is take the number it reports and subtract the bias. So that's actually pretty manageable. On this noisy scale, we can still learn something. Repeating the measures again and again with the same object, the number it gives us does change, but it's changing within a certain neighborhood. We didn't get any surprises like, oh, suddenly this only weighs 10 grams or 10,000 grams. It seemed like it was around like 1,991 to 1,995 or so. So most of the time, we'll probably get an answer within a range, and that range here is only a few grams wide. It's like between 1,991, maybe 1,995. I don't know. I could keep going and figure out how big the range is, but we already have a little bit of a feel for it. And I could tell Melvin that the real weight is somewhere in that range, right? It's not perfectly consistent, but I've got some range that I'm pretty sure the real number is in. And that answer is still a lot better than nothing, even though we will have to live with some ambiguity. I could also study all the scales, sort of like I've done, and I could choose the best one, the scale that is the most consistent and the least biased. And it turns out to be this one, even though this one did have a little bit of a bias in it. But this is a reasonably good quality device from a well-trusted company. And I could tell Melvin that, maybe according to the best scale, the best estimate that we could possibly get, that his grain weighs 631 grams. Of course, there are still some imperfections here. The scale is not completely reliable or completely unbiased. In the real world, in fact, no scale is ever going to be perfect. They can only be accurate enough to be helpful. And the manufacturer of our best scale even reports that it's accurate within about 1 gram. In other words, it can be off by up to 1 gram more or less than the real weight of an object. And for our purposes, that's going to be good enough. Of course, there are situations where it would be entirely insufficient. For example, think of nuclear physicists parceling out just the right amount of uranium. Now, it wouldn't be enough to have a scale that can be off by up to a single gram, because scientists may need to measure differences 1,000,000 times smaller than that. They may even need to measure differences as small as the weight of a single atom, and they would not be able to tolerate the same degree of uncertainty as I would measuring Melvin's breakfast grain. So let's recap. In the real world, no measurement device is absolutely perfect. Measurements can be biased, meaning they consistently over or underestimate their target, and measurements can also be noisy if a device tends to have some random fluctuations. But if we are careful and intentional about understanding our instruments, we can still come to confident conclusions within some limits.